Hi, this is Sawyer and Kai. We are recording our video for our final SIGSYS project. And for our project, we decided to investigate frequency modulation and also made a software simulation to visualize both that and amplitude modulation.
So in class this semester, we learned about amplitude modulation, which is essentially where you multiply some sinusoidal carrier wave by the signal that you want to send, and out comes a signal that is varying in amplitude but has a constant frequency. Frequency modulation is another method of creating a signal to send, but instead of varying the amplitude of a signal, you vary the frequency of a signal. So what you do is when the signal that you want to send is high, the frequency of the signal that you're sending actually increases, and when your data is low, the frequency decreases. So what you end up with is a constant amplitude signal that varies in frequency. So frequency modulation is useful because it's more resistant to noise, because it doesn't care about the amplitude, which is what noise messes with. However, it requires more bandwidth because you need to be able to vary your signal from the carrier frequency on either side.
All right, so now let's take a look at the simulation that we made, which has this neat interface. And to start, we're going to just try amplitude modulation with an empty signal, which obviously if the data is always 0, then the resulting signal should always be 0. You can see that here. We can similarly try an empty signal with frequency modulation, which should, in theory, just return the carrier signal. You can see that here. We can also adjust the frequency of our carrier signal, and that will basically be reflected in our visualization.
So we're going to start by showing you what happens when you're trying to transmit a sinusoidal wave. First with amplitude modulation, I guess. So you can see that in the amplitude modulation, the resulting signal's amplitude varies up and down based on what you're trying to send. And you can see, I guess that's all I need to do. When you do frequency modulation on this sinusoidal wave, the amplitude of the signal that you're sending is constant, but its frequency is actually changes. You can see it has high frequency when the sine is high and low when the sine is low. On the right side here, we have the frequency content of the signal that we're sending. You can see the carrier frequency in green right there, and that's basically like the two impulses that compose the sinusoidal wave's frequency. You can see that the frequency content of the signal that we're sending varies on either side of the carrier frequency by a little bit.
So next we'll just do a simple square wave. Amplitude modulated will basically turn something pretty close to the carrier signal, but will like flip on these hard edges. And you can see our frequency visualization shows the frequency content of the square wave as the shape of a sink. And then frequency modulation will turn up this this signal that sharply contrasts between a high frequency and a low frequency at the edges of the square wave.
Cool. And then one last feature that our little applet has is that you can actually draw any signal that you want to test. So in this case, say we wanted to see what a square wave looked like if we were to use a sawtooth wave if we were to use amplitude and frequency modulation on it. So if we can draw it down here, we'll try amplitude modulation first. You can see that the amplitude increases, and then drops, and then increases again and drops. If you do frequency modulation, you can see that the frequency is low and it increases and then drops to a very low frequency and increases again.
All right, that's all we have for you today. Thank you for watching.